Okay, so we have a tank that stands point down, so my vertex is down, is a cone. So we have a cone that looks like this. It is, okay, we're given that dV/dt is 17 cubic centimeters per minute. Also that the cone is 30, the radius is 11, and we're filling it up and we're trying to find the rate of change of the height of the water, or how fast it's going. So we're trying to find the dH/dt. Okay, so we're given the formula. Okay, so in this case, since I don't know anything about R, I'm going to use similar triangles to solve for R. So R would be 1130 over H. So I'm going to go ahead and substitute that into my volume. Okay, so there's my volume equations all in terms of H. So I'm going to go ahead and take the derivative with respect to time, because we're trying to find how fast, right, the water level is rising. So dV/dt is going to be, right, all of those are coefficients, so I just bring it down. So I'm taking the derivative of h cubed, so that would be 3x squared times dH/dt. I'm going to go ahead and solve for dH/dt because that is what I'm trying to find. Okay, so I'm going to go ahead and enter the information that I know. dV/dt is 17. And at the moment in time, right, I want to find the rate of change at a specific moment in time when H is 13 centimeters. So I get 0.238 centimeters per minute. Okay. Part B says how fast is the radius water surface changing at the moment. So we already have an equation that relates the radius to the height. So I'm going to go ahead and take the derivative of that. So dr dt is going to equal to 1130 dH/dt. So at the specific moment when the height is 13, I know that dH/dt is 0.238. So I'm going to go ahead and substitute that in. And I get 0.087 centimeters per minute.